Hello, welcome to the Superquiz 3 solutions. This is the solution for problem 1a. In this problem, we're asked to compute the limit, if it exists, there's going to be two sequences. So this is just A, where there's one sequence given. And we're told we can assume without proof that the sequence 1 over n to the k converges to 0 for all positive k. As well as any of the properties of sequences or series that have been stated in class or on the homework. Okay, so let's take a look at the given sequence. So let's see now. We're starting with the number 1, and then it becomes 1 plus 1/2, and then 1 plus 1/2 plus 1/3, and then, well, it looks like what we're doing is just taking the previous term in the sequence, and we're adding the next reciprocal, right? So if we're looking for a sub n, right, and I might think of this as a sub 1 and this is a sub 2, a sub n looks like you're going to be adding, so I can use a summation, all the way up until we get to n. And well, we need to use some letter, maybe we'll use a k. It looks like we're adding up 1 over k's, right? So if you're doing like a sub 4, right, you'd be going from 0 to 4, 1 over 4, 1 over k, excuse me. And this would be, well, when k is, we better not start at 0, right? Yeah, that's a bad idea. Okay, we should start at 1. We can see that because if we try to put in 0, we get 1 over 0. And that's right. That's why we started at a sub 1. So when k is 1, we would get 1 over 1, plus, now k is 2, we get 1 over 2, plus, when k is 3, we get 1 over 3, plus, when k is 4, right, which is where we end, we get 1 over 4. Okay, so this is what our sequence looks like, and in class we called this a sum sequence, all right? Because this is built off of another sequence, which would just be the sequence 1 over 1, 1 over 2, 1 over 3, 1 over 4, etc. Right? And so what we're doing is taking this original sequence, which, by the way, in class we gave a name to this. This was called the harmonic sequence. All right? We're taking the sequence and we're building a new sequence by just successively adding more and more terms. Okay, and we actually call that like the harmonic sum sequence. And in fact, the limit, which is, remember, this is what we're trying to do, compute the limit of this sequence, which, like I said, this will be a sum sequence. Well, the limit is what we call the series, right? So the limit of this, right, the limit is, well, what is the limit of the harmonic sum sequence? It's the harmonic series. So is the harmonic series. Right, so the harmonic series, that's what we write as, well, if we use this notation here, we would go k, again, starting at 1 to infinity, 1 over k. And, well, we know this diverges, right? This is the harmonic series. We got to remember that harmonic diverges. So this diverges. Okay, can we give an argument for that? Well, actually, yeah, we can give an argument for that. For example, the p-series test, right? So by the p-series test. Okay, of course, in class we gave other proofs. For example, Nicola Rem's proof from the 1300s, right? So yeah, there we go. All right, so we know that the original sequence, right, which is the sum sequence, which would converge to the series, diverges, and so A diverges. So thus, A bar diverges.